Graph the function f of x equals negative 2x minus 1. Now, if you watch my previous videos, you'll notice that in the last two videos, I had a domain. I gave you specific x values that I wanted you to plug in. Not anymore, but I'm going to treat this in a very similar way. I'm going to make myself a nice little 3-column table like so. I'm going to pick x values and then plug them into f of x equals negative 2x minus 1. When I do that, I'm going to get f of x values for me to graph. And then this problem is different because I'm going to have one more step. So what I said before is I'm going to pick x values. This is, well, never mind. I was going to say something that you're supposed to not know yet, so I won't say anything. I am going to choose negative 2, negative 1, 0, 1, 2. This is the very beginning of graphing functions. So like really, you don't have to be super worried about what numbers to choose when you choose your x values. These are the ones I chose because they're centered nicely around my coordinate plane. So I'm going to say f of negative 2 equals. Now what I do when I plug in negative 2 is I replace x with parentheses negative 2 like that, and then I do whatever math is necessary. Negative 2 times negative 2 is positive 4. Positive 4 minus 1 is 3. Let's do it again. F of negative 1 has me replacing x with parentheses negative 1. Negative 2 times negative 1 is positive 2, and 2 minus 1 is 1. Let's do it again. F of 0 equals negative 2, replace the x with parentheses 0. PEMDAS says negative 2 times 0 is 0, and 0 minus 1 is negative 1. Let's do it again. F of 1 equals negative 2 times 1. Negative 2 times 1 minus 1 is going to be negative 2 times 1 is negative 2. Negative 2 minus 1 is negative 3. And then last but not least, I have f of 2, which has me doing negative 2 times parentheses 2 minus 1. Negative 2 times 2 is negative 4, and negative 4 minus 1 is negative 5. So now that I have these, I can build together these coordinates. I can make my points. When I plugged in negative 2, I got out 3. When I plugged in negative 1, I got out 1. When I plugged in 0, I got out negative 1. When I plugged in 1, I got out negative 3. And when I plugged in 2, I got out negative 5. All right, so I have 5 points that I'm going to graph. And again, I chose 5 x values. If you're wondering, well, could I choose 3? Could I choose 2? Could I choose 1? Listen, you'll see what graph this is going to look like. When you first start out graphing functions, you're going to want to pick about 5 points just to be on the safe side. And that's why I chose 5 points, because I'm a math teacher and that's what I always do. Okay, let me graph this first point, negative 2, 3. Negative 2, 3 has me going from 0, 0, left 2, up 3. So left 1, 2, up 1, 2, 3, put a dot right there. Graphing the point negative 1, 1 has me going left 1, up 1, left 1, up 1, put a dot right there. 0, negative 1 has me not moving and going down 1. So start at 0, 0, don't move, go down 1. Now I have 1, negative 3. So this has me going right 1, down 3. So start at 0, 0, right 1, down 1, 2, 3, put a dot there. And last but not least, I have 2, negative 5. So start at 0, 0, right 2, down 1, 2, 3, 4, 5. Now you will see that what I got are a bunch of dots in a straight line. Am I done? No. And the reason why I'm not done is because if you're not given the domain, your job is to connect these dots. Now, I am absolutely terrible at connecting these dots, so you will see some funny looking shapes pop up. I'm going to get a line because, again, I'm awful at this. So let me get a line. And what we're going to do is we're going to take this line and we're going to use this line to connect the dots. Okay, so connect the dots. And the last thing that we want to do, by the way, let me show you the wrong way of doing it. There. The wrong way of doing it is only connecting the dots that you have. If you're like, well, why not? Those are the dots. Those are the dots that you chose. Exactly. Those are the dots I chose. This is following a pattern. If I were to pick 3, there's going to be another dot right there. If I were to pick -3, there's going to be another dot right there. So when we graph this and we create our line, we make sure that that line covers everything. So what you would want to do if you're using pencil and paper is you would want to use like a ruler and make sure you connect the dots and show that line going throughout the entirety of the coordinate plane. Since this is a line, I'm going to make sure that I put arrowheads at the end of it to show that technically if this coordinate plane was bigger, the line would go even further than what we have. So that's what graphing a function looks like. You pick your points, you plug them in, you get your dots, you graph your dots, you connect the dots, and you put arrows depending on what your graph looks like. Wasn't that fun? It was fun. Thanks for watching.